completely ripped away, leaving a wild, jiggling soup of bare protons and electrons. They are packed together so tightly that they have no choice but to collide. This is nuclear fusion. Protons slam together, fusing into helium. And in that microsecond of violent impact, the tiny packet of energy is born, a photon. But wait, this is not the gentle, warm, yellow light that wakes you up in the morning. Not even close. This newborn photon is a high-energy monster. It is a screaming, lethal gamma-ray photon. If this radiation hit you right now, it would shred your cellular structure instantly. Now watch what this implies. This monster photon is born with a single desperate urge: to escape into the wild void of space. And it has the ultimate tool to do it: speed. It travels at the universal speed limit of 300,000 kilometers per second. At that blinding speed, it should zip from the center of the sun to the outer edge in just over 2 seconds. 2 seconds to freedom, right? Wrong. Stop. Think about the reality of this crowded engine room. The photon takes its very first step, ready to fly. But it cannot even travel the width of a single hair before it slams headfirst into another particle. The escape journey does not take 2 seconds. It takes tens of thousands of years. That sounds impossible until you see the physical trick of how light actually travels through this dense cosmic crowd. To understand this trap, we have to look at the bizarre math of the journey itself. We call this journey a random walk. It is a mathematical nightmare of epic proportions, and it turns our speed of light champion into a blindfolded runner trapped in an infinite hall of mirrors. Imagine a crowded bar on New Year's Eve. It is packed wall to wall with thousands of people, all jiggling, laughing, and bumping into each other. Now imagine someone who has had way too much to drink. We blindfold them, spin them around, and ask them to walk out the exit. What happens? They take one step forward, slam into someone, and bounce to the left. They take another step, hit a wall, and bounce backward. They are moving, but they are going absolutely nowhere. This is what mathematicians call the random walk, and it is the exact physical reality of our newborn photon. Here is the part nobody tells you. In the vacuum of space, a photon moves in a beautiful straight line, but inside the sun's core, it cannot do that. The density is so absurdly high that the average distance a photon can travel before hitting something is microscopic. We call this the mean free path of about 0.1 millimeters. Wait, look at that number. 1/10 of a single millimeter. That is the thickness of a sheet of paper. The photon takes a tiny step, travels less than a hair's width, and smash! It collides with a free electron. The electron absorbs it, instantly spits it back out, but in a completely random direction. Maybe left, maybe right back where it started. This is where your intuition fails. You would think that after 1 billion bounces, the photon would make some progress. Mathematically, the net distance d traveled after n random steps is only d equals d times n, where d is the step size. Let that sink in for a second. To travel just 1 meter from the center, the math gets brutal. Because of that square root, the number of steps required does not grow linearly, it explodes exponentially. Picture taking